Welcome to PyKMD. PyKMD is an app that serves for data-driven modeling and prediction of dynamical systems. It works with time series data and is fully based on the Koopman operator theory. In this video, I'll give you an overview of our app and walk you through its features. This is the Data Input and Preprocessing tab. Here, you can upload new data, use data you've previously uploaded, or select a sample dataset. Let's load one of our sample datasets. We've loaded the Earth orbit data provided by NASA's Jet Propulsion Laboratory. This dataset has three columns: r, which is the distance between the Sun and the Earth in kilometers; r dot, which is the difference between the current r value and the previous one in multiples of 100,000 kilometers; and angle, which is measured in degrees. On the left, we can see some information about the data. There are 731 rows and 3 columns. If we'd like, we can downsize our data by specifying the start, end, and step for rows or by deselecting columns. To finalize any changes, click Downsize Rows and Columns. For this example, we'll just look at r and r dot. Now that we've removed the angle column, we can add new transformed observables. There are 3 different options for adding columns. In this video, we won't be using them, but if you want to learn more about these options, please watch our in-depth video on the Input and Preprocessing tab. As we can see in this example, the scale of the numbers in the r and r dot columns is quite different. We can standardize each one by clicking on the drop-down at the top of the data table and then selecting Standardize. Even if your data is on a similar scale, it's best practice to standardize. Now that we've standardized our data, we can split it into training and testing data. So in the bottom left corner, we'll do this with a 90:10 training to testing ratio. We see in the bottom right corner a confirmation that our data was split correctly. We also see that our standardization procedure has been reapplied to our training data. This is very important for preventing data leakage. Now we can move on to the lifting process. Let's go to our second tab. In the lifting tab, we can embed time delays into our data using Hankel lifting. This means we take our original time series and create a new dataset where each row includes the original value and several previous values. This is useful for capturing the dynamics of the system more effectively. In this case, we'll use one delay and leave the thinning step at 1. For more information on Hankel lifting and the time delays and thinning parameters, please watch our in-depth video on the lifting tab. Below the time delay and thinning step inputs, we see information about the resulting lifted matrix. Now, let's click on the Lift button to apply the lifting. To the right, we can see a preview of the Hankel matrix. Now, we can move on to the DMD tab. Here, we will perform Dynamic Mode Decomposition, or DMD. DMD is a technique we use to extract spatiotemporal patterns, or modes, from our time series data. On the left, we have the settings for DMD. In this case, we'll mostly use the default settings, but we will refine the modes and force a numerical rank of 2. For more detailed information on DMD and the settings, watch our dedicated video on the DMD tab. Now that we've selected our settings, we can perform DMD by clicking the Perform DMD button. To the right, we can see a table with our RITS values, colored by their norm. These values are also displayed in the complex plane to the right. Now that we've performed DMD, we can proceed to the next tab. In the Mode Reduction tab, we can reduce the model by removing certain modes. In this case, we will keep all modes. For more information on how to effectively use this feature, please watch our dedicated video on the Mode Reduction tab. We will also calculate reconstruction coefficients by clicking the Coefficients button down here. Again, for more detailed information, you can refer to our Mode Reduction tab video. To the right, we see the RITS values and their corresponding reconstruction coefficients in a table, colored by the reconstruction coefficient norm. These values are also displayed in the complex plane on the right. Now that our model is fully computed, we can proceed to reconstruct and predict in the next tab. In the Koopman Modeling tab, we can use our model to reconstruct the original data or predict out of sample data. First, let's take a look at the reconstruction. To the right, we see a graph of the reconstruction versus the original data. We also see reconstruction error metrics off to the right side of the graph. We can change which variables are being graphed on the x and y axes. Let's see the reconstruction for r dot by selecting it in the drop-down menu. Given that we are using only 2 RITS values, the reconstruction for r dot is also very good. Now, let's see how our model performs on out-of-sample data. To do this, we can predict. Let's set the horizon to 100 time steps. We now see the reconstruction, prediction, and original data all on the same graph. The prediction for r dot is very accurate. We also see that prediction for r is very good. For more detailed information about this tab, please watch our Koopman Modeling tab video. We can also examine the Koopman operator itself. To do this, we can go to the next tab. Let's click on the Show Koopman Operator button. Here, we can see a heat map of the Koopman matrix. You can download this matrix for offline analysis by hovering over the graph and clicking on the Download Koopman Operator as MPY button. Please also note that other tabs allow downloading data for offline analyses, such as the resulting RITS values in the DMD tab. For more detailed information, please watch our Operator Heat Map tab video. Now, let's move on to the Settings tab. Here, you can adjust settings related to your experience within PyKMD. When you change settings, they are applied immediately. For example, in this demo, I've turned off the tooltips. If I were to turn them back on, you'd immediately see that the tooltips come back. If you click Save Settings, these settings will be automatically loaded in for future sessions. The Restore Settings button allows you to revert to your saved settings if you make any changes. Finally, once you're done in PyKMD, you can click the Home button in the top right corner to navigate back to the home page where you can log out or navigate to a different AIMDyn app. Thank you for watching, and if you have any questions, feel free to reach out to our team at apps@aimdyn.com.